Hello, this is Dr. Otterberg, and I'd like to welcome you back to Introduction to Reinforcement Learning Motion Control. And the topic of our lesson today is the difference between PID and reinforcement learning product development. What we see here is a similar slide that we saw previously in previous section, which was the pyramid of value. And what we saw is that the team which are working on PID product development, pretty much including mechanical engineer, electrical engineer, and computer scientists, they receive from the marketing managers, the business administration, the specification of the needs, and they prepare both the machine, the sensors, the electrical equipment, and the software that goes inside the motion controller to run the system. So these are the team members, the main team members. Of course, there are many more, but the main team members that develop PID motion control system. And we also saw that when we're dealing with reinforcement learning, we must have also an AI machine learning specialist. It's not that we have as a mechatronic engineer, there need to be one, but we have to identify an AI machine learning specialist and have him join our team. And he will work, he or she will work very closely with the system analyst. Now, when we're talking about the process with reinforcement learning starts exactly with the same definition, specification of the marketing business administration in a way that will make the company more competitive. And will create products which are more difficult for competition that doesn't have it to do. With this specification, the system analyst will have to start building up the simulation and animation of the system that is being intended to be developed. And this is before anything else is being done. Or perhaps if you have a standard equipment when it is being done, but before it's being tested. Once the analysis is being done and the environment is animated, then this simulation is integrated into the artificial intelligence agent, which was selected by the artificial intelligence machine learning expert. And with the reward process, and many times the reward process will be an input from all team members, such as safety, for example, from the mobility, such as minimum energy from the EE. All these elements, including the specifications, if it's medical exoskeleton, for example, from a doctor that requires minimum reactions at a certain location of the body, which is connected to the exoskeleton. All of these go into a reward function. And once the neural network controller is being optimized, then it actually deploys into the hardware, which will run the reinforcement learning machine. It will not have any of this simulation or modeling in it. It will run exactly like the PID motion controller runs, but instead of having only 3 parameters, you'll have actually hundreds of trained parameters. Let's take a little different look at it when we see the difference between the product development process. We saw the block diagram of the PID motion controller earlier, and we saw how the PID fits an amplifier, which goes into the motors. The motors actually act on a machine together with motion disturbances that come from the environment. And that result, which is the position and velocity, are being measured by sensors being fed back into the PID, also with the arrow between the desired motion profile and the actual one. And this is the straightforward job. And the common PID controller looks like that, and it is connected into the final machine, final hardware, and actually can be tuned and tested while it is connected to it. Unlike PID, we have a more complex product development process, as we saw earlier. We'll see it now in a slightly different way. So we say that the marketing and customers actually define the needs. And then this is defined over here in this area. And all the specifications of the machine. And then the system analyst develop the analysis and actually comes to a point where the system analyst needs to validate that the results that they're getting, the profile, the motion profile that they're getting, actually satisfy the need. And when this is done, if a check is positive and the simulation is confirmed to be good and acceptable, then it can go forward to check more specifications such as safety, for example, and before it can move forward to the simulation with the reinforcement learning. Now, if the check over here is not validated, then there is an iterative process where parameters have to be checked and changed, and the whole simulation must be modified in order to be more similar to the actual environment. And the same thing here. If in the check of certain specifications, the machine simulation doesn't meet the criteria, the needs, perhaps we see faults in the specifications, then it goes back to these teams in order to come back and iterate and try to get a better qualified simulation that we can use further in a reinforcement learning system. Once the system simulation is validated, approved, maybe tested in a lab to see that it's okay, then it actually can be used to set up a reference point for the final system, the actual system. But before that is being done, it will go into the reinforcement learning simulation and learning process. The simulation itself that was developed over here in the planning phase will go over here to mimic the environment. So it will act here exactly like it was acting here. And it's not going to be the real machine like it is over here. It's just going to be the simulation of the machine, very similar, but the simulation. And then what happens is the simulation will run with the neural network controller. The neural network controller will have hundreds of parameters, and these parameters will receive feedback from the system, from the environment, which is actually the state. They will also check the error. The state will also feed into the reward function, and the result will be the action, and the action will also feed into the reward function. Both the state and the action will give a reward for the iteration of the process. And then using optimization technique, so-called linear programming, as determined by the specific agent that the specialist has selected for the job. And once the iteration is done, then the neural network set of parameters are being optimized. And this being done in many episodes, as we saw earlier. And once there is a convergence of the reward, both by the critic and the actor, as we'll see later when we look at more details on the block diagram features, then when it's actually converged and the training is completed, then the neural network is being deployed into the controller, and then the controller continues to act very similarly like the PID controller. So this process is not very common today. Hopefully our students will find interest in order to learn more about it and try to make it more easily planted into a autonomous system that their company or startup will be interested in developing. The resulting hardware in which the neural network will rest in, as we see over here, may not look different than the PID controller. But the technology inside and the tools which will allow, for example, the tensor flow mathematics multiplication of hundreds of parameters in real time, very, very fast, has to be developed in special hardware. And as we see over here, Intel, for example, bought an Israeli AI company that make chips for AI products. They spent $2 billion in buying it. So this completes our presentation. Hopefully we'll learn a little bit about the differences between common PID product development and reinforcement learning, which is a lot more complex. In the upcoming section, we'll take a deeper look at each one of the reinforcement learning components. Thank you.